Bismillahirrahmanirrahim. Today we are going to learn about the chapter that is the energy from chemicals. So in this chapter, first of all, we would like to cover the exothermic reaction. What does it mean, exothermic reaction? Exo mean exit and therm mean heat. So basically exothermic reaction is basically the type of reaction in which heat is given out. So if we will say this is the system, a reaction is going to take place, then heat is given out to the surrounding. When an anhydrous sodium carbonate or sodium hydroxide pellets which dissolve in water, so then there is an increase in temperature. So the mixture then loses heat to the surrounding as it cools down again. But when we are going to say that it is going to produce heat to the surrounding, then we can record and prove it by the reading of thermometer. So this thermometer proved helpful to tell us that this reaction is exothermic. We will record the initial reading. For example, initial reading is 30 degrees centigrade. After this reaction, if it is going to be 45 degrees centigrade, then we will say that rise in temperature is of 15 degrees centigrade. So after having a look on these readings, we can confirm that this reaction is exothermic. There is another way through which we can learn that this reaction is exothermic by touching this beaker. So if it is going to be heated up, then we will say that this reaction is exothermic reaction. Then in that case, we can look at this graph where direction of reaction is given like this. After reaction at room temperature, first reaction will start at room temperature, and then it will reach towards the maximum temperature which it will attain. After that, it will come down and cools down. So hence the solution has less energy than the solid and water at the start. So this is the way through which we can describe this is the exothermic reaction. So what does the meaning of surrounding? If we will talk about the surrounding, that heat is released to the surrounding or given out to the surrounding. So surrounding is our solvent. If we are going to take water especially, then we can say that surrounding, the solvent or water is our surrounding. Air around the test tube or around the beaker is the surrounding. This beaker, or if we will use the test tube, then the test tube itself will be the surrounding. The thermometer is the surrounding. So all the part which is not reacted in the reaction or not part of the chemical reaction is called as the surrounding. So this is the surrounding which we are going to describe for this system. Okay, then energy level diagram for exothermic reaction can be described as that products have the solution where product is formed has less energy. The solution has less energy than the solid and water at the start. So at the beginning, whatever is the energy, it is going to have less energy. So products have less energy than the reactants. So this is the energy level diagram. Why products have less energy? Because all of the heat energy is released or given out to the surrounding. So we will say that this product has less energy. Move towards the endothermic reactions. So what basically endothermic reaction is? Endo mean in, therm mean heat. So endothermic reaction is the such type of reaction in which heat is taken in from the surrounding. All the heat is taken in. So for this purpose, if we will talk about this example, if we will dissolve ammonium chloride in water, there is a decrease in temperature. So the mixture takes in heat from the surrounding. This is the surrounding from where it will take the heat. As it warms up again. It warms up again, but this beaker will again, we will say the solution has more energy than the solid and water at the start. So this pan will become cool. So when it is going to absorb heat from the surroundings, so all the product reactants have less energy, whereas products has more energy. And when products have more energy in itself, in it, then the surrounding will have less energy. We can describe this by this having a look on this graph, where we can say that reaction progress, this is the direction of reaction. Direction of reaction. In endothermic reaction, temperature falls and will attain minimum temperature which it wants to be. Then after some time it will come again towards its room temperature. So this is the way through which we can describe the endothermic reactions, in which heat is absorbed from the surrounding and products have more energy. We are going to talk about products have more energy, whereas in exothermic reactions products have less energy. Why? Because all of the heat energy is released or given to the surrounding. So another important question, that where chemical energies come from? Okay, where chemical energies come from? So basically bond energies is going to describe that how can we describe that either the reaction is exothermic in terms of bond energies or endothermic. If we have two atoms like hydrogen and hydrogen, so if we will describe it, two atoms are there. So these two atoms are going to combine together to form a molecule that is the hydrogen molecule. So if we are going to discuss that there is the hydrogen molecule, a new bond is formed. So when two atoms are joined together by a chemical bond, if we will say that two atoms are joined together by a chemical bond, then heat energy is given out. So here we can write and say that when bonds are formed, heat energy is given out. When bonds are formed, we will say that heat energy is given out. Heat energy is given out. Now in next, when we are going to discuss about the covalent bonds, so when this covalent bond is formed, energy is released with this negative sign, that is 436 kilojoules. So when two atoms of a hydrogen atoms combine together to form one molecule of hydrogen gas, then we will say that minus 436 kilojoule energy will be released. So bonds formation is given as the loss of heat. So now then when the covalent bond is formed, 436 energy is given out. But same energy is absorbed when covalent molecule of hydrogen, if we will say this is the molecule of hydrogen, so this is the covalent bond in the hydrogen molecule. When this covalent bond, if we are going to talk about this covalent bond, when this covalent bond is broken, then what will happen? We will gain two hydrogen atoms. So whenever we have to break the bond, we have to provide the heat energy. So same amount of heat energy will be absorbed or taken in. So same word will be used. So heat will be provided to break this bond. So in order to break this bond, to convert into the hydrogen atom, we have to provide heat, and this hydrogen molecule will absorb heat. So we can write it here that bonds broken, in bonds broken, heat energy is absorbed. Heat energy is absorbed. So this is the way through which we can describe how bond energies are involved in it. But if you are going to get a question like describe either the reaction is in terms of bond breaking and making, either the reaction is exothermic or endothermic, what we will say? Remember, Whenever chemical bonds are made between two atoms, heat energy is given out. So the change is exothermic. This change is exothermic. So we will describe change is exothermic. In each and every reaction, bonds are broken down and bonds are formed. When bonds are formed, we will say that this is reaction. Exothermic reactions, when bonds will be broken down, we will say this is the endothermic reactions. If more energy is released in bonds formation, if more energy is released in bond formation, then we will say the reaction is exothermic. If more energy is absorbed then released, then we will say the reaction is endothermic. So bonds broken is the endothermic process in which heat is absorbed or taken in. So this is what we have learned today about the exothermic and endothermic reactions. In the next lesson, we are going to discuss about the energy profile diagrams of exothermic reactions and endothermic reactions. I hope so that you people have learned it very well. Consistency is the key of success. Signing off, Miss Aisha Manzoor.